This is lesson 7.5, part 2. We're going to talk about the properties of kites. So our last quadrilateral that we're going to talk about is a kite. And a kite is a quadrilateral that has exactly two pairs of consecutive congruent sides. So instead of the sides across from each other being the same, there are sides next to each other that are the same. So AB is the same as AD, and BC is the same as DC. There's going to be only one pair of opposite angles that are congruent, and it's specifically the pair between sides that are marked differently. So here AB is marked with 1 dash, and BC was marked with 2. So where they meet is where my congruent angle is. So the ones across from each other here, angle ABC, and angle ADC are the ones that are congruent. And the diagonals are perpendicular. So the diagonal here, BD, is perpendicular to the diagonal here, AC. There's actually a bunch more stuff that we could show once the diagonals are in, like the fact that the non-congruent angles are actually bisected. So this little piece here is the same as this little piece here, and this one here is the same as this one here. But that's not actually described to us. That's just something we can prove by proving the two triangles are congruent and then using CP/CTC. So for example 1, we know that these two angles, because they're between the different sides, are the same. So whatever they are, they're both x. The other thing we know is every quadrilateral adds to 360. So that way we can say that x plus 85 plus 43 is equal to 360. So that's going to be 2x plus 128 equals 360. So take away the 128, we get 232. And when we divide by 2, both of those angles are 116 degrees. So here's one for you to try. Give it a pause. Answers are posted on Google Classroom. For example 2. I'm actually going to look at what they want me to find before I find everything in this picture, because there's a lot of missing angles and I don't want to find them all. So the first thing they ask for is PTQ. So that's the angle where the diagonals intersect, and it's a right angle. So that's 90 degrees, right? The diagonals are perpendicular. The next one is PQT, this corner over here. So I know it's part of a right triangle. I know one angle's 37, one angle's 90, and then I'm looking for angle PQT. So if I add together the 90 and 37, we get 127, and then take that away from the 180 for a triangle, and we get 53 degrees. The last one is QRT. QRT. This is actually the same as this, because again, I can prove that these two triangles were congruent to each other. So this is just 37 degrees. Here's check-in 2. You could pause. Answers are posted on Google Classroom. All right, so here, example 3, we have almost every angle that we're going to find in our picture. I'm going to start with angle 3 because I know that I have right angles in all 4 spots here. So angle 3 is 90 degrees. I also know these two angles are the same as each other. So 7 is also 52. I know that these two angles are the same as each other. So 4 is 65 degrees. And that's all I've got so far. So I'm going to use this knowledge. I'm going to say in this triangle, I have the 52 degrees, the 90 degrees, and angle 6. So angle 6 plus 52 plus 90 would be 180. So that's 142, and 180 minus 142 is 38. So angle 6 is 38 degrees. 6 is the same as 5. So angle 5 is 38 degrees. My last two angles are 1 and 2, and they're going to be the same as each other as well. So I'm going to use this triangle now because I have 65, 90, and angle 1. So angle 1 plus 65 plus 90 would be 180. So 65 and 90 is 155, and if I take that away from the 180, I get each of those angles was 25 degrees. So here's one of those for you to try. Pause. Answers are posted on Google Classroom. So for example 4, we want to find the measure of angle S. These sides are different, so this angle and this angle are the same. So I can set 13x minus 32, equal to 7x plus 22. Subtract the 7x, add the 32, divide by the 6, we get x is 9. So if I'm looking for the measure of angle S, I'm going to put that back into 13 times 9 minus 32. So that's 117 minus 32. So the measure of angle S is 85 degrees. So there's a check-in here for you to try. Pause. Answers are posted on Google Classroom. For example 5, I know that these sides are different, so these angles are the same. I could put another 109 here. And now I have the 4 angles of a quadrilateral, and all quadrilaterals add to 360. So we'll add our 4 angles together. And we're going to set it equal to 360. So it's 5x and 3x is 8x. 109 and 109 is 218, plus 14 plus 8 is 240. Take away our 240, so 8x equals 120. And when we divide by 8, we get x equals 15. And there was nothing to plug back in for this one. They just wanted us to solve for x. So here's a check-in for you to try. You can pause. Answers are posted on Google Classroom. Okay, for our last one, we have an angle that was bisected, so I know that these two are equal. 9x minus 1 is equal to 2x plus 13. I'm going to subtract 2x. I'm going to add 1 and divide by 7, so x is 2. And they want angle EDC. So they want this angle here. I know I have a right angle, and I have the angle that was 2x plus 13, and I now know what x is, and these three should add to 180. So if I take the 2 and put it back in first, 4 plus 13 is 17 degrees. We're really going to do 90 plus 17 plus our mystery angle. I shouldn't call it x. We already have an x in the problem. Let's call it y. Equals 180. So this is going to be 107 plus y is 180. So that angle, I'm going to call it measure of angle EDC, is equal to, let's take away the 107, 73 degrees. So here's the final check-in. Pause or end the video. That is the end of 7.5 part 2, properties of kites.